Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Confederation of Pentominoes by Will Power, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have killer cages, where numbers in cages sum to 25. That's just the long and short of it. We have whispers, where numbers on a green line are at least 5 apart from their neighbors on the line. And numbers on the red line are at least 4 apart from the neighbors on the line. So these are what I like to call Whisper 5 and Whisper 4 lines, and these are not my designations. These are something that one setter came up with, and I thought was brilliant because it was a very smart way, because you could actually also have Whisper 3 lines, Whisper 6 lines, however many number of Whisper lines you want, Whisper 10 lines, Whisper 15 lines even, and it still works. So this is what I prefer calling them. It's not something that's just for me personally. I just think it just makes sense from an extensibility possibility. So that's just the way I think of things. So for the Whisper 5 lines, for example, if this were, say, a 3, this would have to be 8 or 9 to be on the Whisper 5 line, right? Because those are the only digits which are 5 or more away from 3. That's the reason why that would be the case. If, say, this were a 3, though, this could be 7, 8, or 9 on the Whisper 4 lines, because those are the digits which are 4 or more away from 3. And those are examples of how Whisper 5 and Whisper 4 lines work. We have Renban, where numbers on purple lines are a set of non-repeating consecutive numbers in any order. Or, as you can see, they would be also similar to essentially having a Kropke dot in between them. I'm not really sure why we have Renban particularly there, but we'll get to that in the next case. We have a magic square where in box 1 forms a magic square where all rows, columns, and diagonals in box 1 sum to 15. So this sums to 15, this sums to 15, this sums to 15, this sums to 15, etc., etc. So that's an example of how... So a magic square basically means this must add up to 15 for every 3 cells in every row, column, and diagonal. And that's how magic squares work. We have Kropke pairs, where numbers with a white dot between them are consecutive. So that's basically the same as the Renban lines, since the Renban lines are only 2 apart, so they must form a set of consecutive digits. Well, that 2 digits being consecutive is the same as having a white dot in between them. But yeah, so these are consecutive between them, and numbers with a black dot between them are in a ratio of 2 to 1. Not all possible dots are necessarily given. He says specifically not all possible dots are given, but it could be that these are the only 1 to 2 ratios and the only consecutive digits. So if, for example, this was, say, a 6, this would have to be 5 or 7 to be consecutive. It's the same thing with the Renban. If this were 6, this would have to be 5 or 7 to make sure that these digits are consecutive. And if this were, say, a 2, this would have to be 1 or 4 to maintain the 1 to 2 ratio between them. And those are examples of how Kropke pairs work. And finally, we have odd and even, where cells with a gray circle in them are odd, and cells with a gray square are even. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so the one that makes the most sense to me to look at, well, these are all odd in box 8, so therefore these must be all even. These are all even in box 3, so the rest must be all odd. And the even cells have to add up to 20, right? Because it's 2, 4, 6, and 8. So therefore that adds up to 20, which means the remaining digit in that cage is a 5. We also have magic square where we know the 5 has to be in the middle because it has to add up with 4 other pairs of digits to add up to 15. The only digit which can do that is 5, right? 4 and 6 can add up with 3 other digits to add up to, if they're all unique, I should say. So since all the other digits are unique, they must add up with 1 digit as a pair. So they add up with another digit with a single digit to add up to 15. And you have to do that 4 times, right? You have these two adding up to 15 with this digit, these two adding up to 15 with this digit, these two adding up to 15 with this digit, and these two adding up to 15 with this digit. So no matter what, this digit is going to add up with the 4 other digits, 4 pairs of other digits, which all of them are unique sets from each other. All of them are unique digits from each other, shall we say. And therefore, they must add up to 15 either way. The only way you can do that is, that means you have 4 sets. They must all add up to 15 again. So that means 4 times this digit plus all the other digits must equal 15 times 4, which is 60, right? Yeah, the only way that works out so you have everything minus x plus 4x equals 60, right? Because it must be 15 times 4 times. So that means if you have, so it's 45 minus x on plus 4x on one side. So that's 45 plus 3x equals 60. Subtract 45 from both sides, 3x equals 60 minus 45, which is 15. So then divide by 3, you get x equals 5. So no matter what, this is 5 in the middle. I guess that's the better way of putting it is, okay, so then the question is, what about the digits on the outside? And each of those must add up to 15. Here it must be with 2 other unique digits, and then on the cross it must be with 2 unique digits. So these two must be the same parity to add up to 15, because they add up to an even sum without the 5, and then 10, because they add up to 10. 10 plus 5 is 15 then. So if we know one of these are consecutive. One of these is even, and one of these is odd, because they're consecutive, right? So we have 3 evens in row 2. If we had this as even, the problem is that doesn't work. And also because it's a magic square, we also know this can't be even. Because if you have even here, that's the only way you can get, you can't get even digits can add up with 3 unique sets to add up to 15. Odd digits cannot, though, right? Because if you have 5, and say you had a 7, you have 3, 5, and 7 adding up to 15, obviously. then what other sets can you add up to 15 with? 7 would have to have 2 even digits to add up to an odd digit, right? Or 2 odd digits. But we already know that this 5 is in the middle of either 2 even digits or 2 odd digits in each row, column, and diagonal. So you're not going to get 2 odd digits in the row or the column if it were in the corner, adding up with 3 other digits. Or, sorry, adding up 3 times to 15. So if you had an odd in the corner, well, first of all, there would have to be evens in the... You'd have to have... Yeah, if you have an odd in the corner, the only way you can add up to 15 is 2 evens and 2 evens. You can't have 2 odds, because then you would have something like 3 odds here and then odd here. But these 2 odds would have to add up with another odd digit to add up to 10, so that this would add up to 15, which is not allowed. So this is just not going to work. So it has to be even, and then you still have that problem, right? You have 4 evens, and these would have to be odd, and then these are never going to add up to 15. So that's the reason why you can't have odds in the corners, aside from, just basically in a magic square in general. So the odds always are going to be in the cross of, essentially, or the plus sign of a magic square, and the evens are going to be in the corners. This is 1 odd and 1 even, and because we have a 1 odd and 1 even here, we have 5 odds in row 2. So this cannot be odd, it's even, guaranteed. This is 1 odd and 1 even in row 3. That leaves us 4 evens in row 3 already, so this can't be even, this is odd. Okay, what else do we have? We know this digit has to be 2 or 4 to be in a 1 to 2 ratio with 2 other unique digits, right? So this is even. And we know 2 and 4 in this set have to be in that relationship, right? It's either 2 with 1 and 4 in a 1 to 2 ratio, or it's 4 with 2 and 8 with that in a 1 to 2 ratio. Okay. We know these are all consecutive. That's interesting, right? So this forms this is essentially, you could, well, it's not a Renban because it's guaranteed. This is, so, yeah. This must be 1 through 8 or 2 through 9 in one way or the other. So then this has to be 1 or 9 here. And we don't know about this. If this is 1, 2, 4, that would be 25 minus 7, which is 18, which is not allowed. 2 digits adding up to 18, that's the remaining digits, right? So if we try to have this as 2 and this is 1, 4, you can't have 2 other unique digits adding up with that to add up to 25. So this must be 4 and 2, 8 as a pair. So these are all even, which means the remaining digits, we have one pair here that is consecutive. So one of these is even, the other one's odd, which means we have accounted for in row 5 4 evens already. So the rest of the digits are odd. So this is odd, this is odd, this is odd. So if this goes from 1 through 8 or 2 through 9, right? This is the end of one part, and this is the end of the other part. Since this is odd, this must be even, which forces this to be odd, which makes this even, which makes that odd, makes that even, makes that odd, which makes that even. So then this is odd, because it's 1 or 9. This must be the other 1 or 9 then. 1, 9, 2, 8, 3, 7, 4, 6. This is 5. We have 4 or 6, 3 or 7, and 2 or 8 here. So we have a 5, 1, 9 triplet. So this is 2, 4, and 8. That means this is 14, which means the remaining digits add up to 25 minus 14, which is 11. You can't have 2, 9, 3, 8, or 4, 7 here. It must be a 5, 6 pair. Okay. Remaining digits in row 5 are 3, 6, and 7. The only ones which are consecutive with each other are 6 and 7. So this is a 6, 7 pair. This is 3. If this were 6, it would have to guarantee a 5 there. So this cannot be 6. This must be 7, this must be 6, and this must be 8 to be consecutive. 3, 6, and 7 add up to 15, so this must be 8 and 2 to add up to 10. Right, 10. Wait, no, that's not right. 3, 6, and 7. This is 8 and 1. Right, this is 21 plus 3 is 24. 25 minus 24 is what? I don't know why. I had that wrong. Anyways, this cannot be blue. This is red. Can't be red. That's blue. This is blue here. So 8 eliminates 8 here. So this must be 2, which is consecutive with 1 and 3, which forces this to be 4, this to be 6, this to be 7, that to be 8. Okay. These are all odd digits. These are all even. Here, you have... we cannot have 1, 2, or 8 here on this Whisper 5 line. So what does that mean we can have here? You could have 3, 4 with 9. If 9 is the middle. You can't... Okay, what... If you had this as... Okay, so on a Whisper 5 line, you'll alternate between low digits and high digits. Because what digits can be next to a low digit, which is 1 through 4? This 1 eliminates 1 here, so this is 9. What low digits can be next to 1 through 4, which are the low digits, on a Whisper 5 line? 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can be next to only 9. So next to a low digit, you'll always have a high digit, and next to a high digit, you'll always have a low digit. Well, what happens if we have a low digit here? You can't have 1 or 2 as a low digit, so the next minimum would be 3. And to have it next to 2 unique digits is not possible here. So this cannot be a low digit, right? Because if this were 3, you can only have it next to 8 and 9 on a Whisper 5 line. And that's not possible because of 8 in the column. So this has to be a high digit here. And it's odd, and it's 9. 9 is next to 3 and 4 on the Whisper 5 line, which is next to 1 or 2 also here. And then this must be a high digit, so it cannot be 6, it has to be 7 or 8 here. We know this adds up to 9 plus 3 plus 4 is 16, so this must add up to 9, so this is fine. 1, 8, or 2, 7 works here. Anyways, the remaining digits in column 9 then have to be 6 and 7. So this is 6 as the even digit, this is 7 as the odd digit. One of these is even, one of these is odd. 6 cannot be either of these. Therefore, where is the 6 in this magic square? It must be there, which means 4 has to be opposite it to add up to 15. This is 2, 4, or 8 as even digits, which eliminates 2 in the rest of the column. So this cannot be 2. This is 1. To be next to 9 on a Whisper 5 line. And that for 3, 4, 1, and 9 add up to 17, which forces this to be 8. So this is an even digit here. This is odd. This is odd. Remaining digits in this box 3 are 1, 3, and 9. Okay. 4 cannot be here, but 4 could be either of these. Remaining digits in column 7 are 2 and 7. Remaining digits in column 8 are 5 and 6. Okay. What digits can this be? Without a 7, this has to be 1 and 9 as a pair to add up to 15 for these 3 cells. So this must be 3, 7 as a pair. 3 cannot be here because of 3 in the column. So this is 7, that's 3. That eliminates 3 here, and 7. So the odd digit in this Renban is 1 or 9, which means it must be with 2 or 8 to be consecutive. Okay. And if it's 1 and 2, that's interesting. If it's 1 and 2, I think you need... Okay. If it's 1 and 2, this cannot be 4, 5, or 6 here. This is 2, 4, or 8 here. Cannot be 6. Remaining digits in column 5 are 1, 2, 3, 7, 8, and 9. Interesting. This can't be 7 because of 7 in the row. So this is consecutive with 1, 2, 3, 4, or 8 and 9. Interesting. You cannot have 3 and... You can't have 1, 2, 3, 4 here, right? So if this is not 8, 9 here... That's interesting. So what happens if this is... If this is 1, 2... Then the problem is either this is 3, 4 here, because that's only possibilities we can have on this Renban, or this is 8 and 9. And 1, 2, and 8, 9 add up to 20, which would force that to be 5, which is not possible. Also, where is the 5 in this box? Can't be here because of 5's in the row. Can't be here because of the way the Renban works. So 5 necessarily has to be there. Yeah, so this can't be 1, 2, because if this were 1, 2, again, the problem is it would be with 8 and 9 here, guaranteed. If we try to have 3, 4, 1, 2, 3, 4 only adds up to 10, so a single digit would have to add up to 15, which is not possible. And if we have 1, 2, 8, and 9 here, this would guarantee 5 would have to be here, but it can't be there because of 5 in the row and 5, 6 pair in the column. So... this can never be 1, 2. This has to be 8 and 9, which eliminates 8 and 9 in the rest of the box and row. So this can't be 8 and 9. This is not 9. This is 1. So no 1 here. Again, this cannot be 1, 2, because it runs into the same problem of 1, 2 plus 8, 9 is 20. That requires a 5 there, which cannot be. So this cannot be 1. And we know... this is 3 with 2 or 4. This can't be 8. We have a 2, 3, 4 triplet in box 2, which eliminates 2, 3, and 4 in the rest of the box. So this is 17 already. You cannot have a 7 here. So 25 minus 17, the reason why you can't have a 7 is 25 minus 17 is 8. And to add up to 8 for 3 digits, it's either 1, 2, 5 or 1, 3, 4. So this must be 1, 3, and 4. Which means this can't be 4, that's 2, which means this can't be 2, so it's 4. So no 4 here, no 4 here. 3 eliminates 3 here, so this is 9 and 3. 9 eliminates 9 here, so it's 1 and 9. This can't be 4 anymore, so where's the 4? It has to be here to add up to 8. To 15 with a 6. So this must be 2 and 8 and 2 and 8. 4, 9, and 2 add up to 15, so this is 2. That 6, 7, and 2 add up to 15. 6, 1, and 8 add up to 15, so does 8, 3, and 4. And that satisfies the magic square. This 8 eliminates 8 in the rest of the row, so this is 2, which makes this 8. This 2 eliminates 2 in the rest of the column, so this is 8, which makes this 2. 4 is even, 3 is odd, and so is 1. We have 4 evens in column 4, so the rest of the column is odd. We have 5 odds in row 1, so that means this is even here. And this must be 6 here. This has to be 6 here. That eliminates 6 in the rest of the row, so this is 5 and 6. 5 is odd. 6 is even. We have 4 evens in column 6, which eliminates evens in the rest of the column. This can't be even, that's odd, which means this can't be odd, that's even. That leaves these as odd. So this is 9 as an odd digit. This is 8, this is 7. Okay, where is 7 in box 5? Cannot be here or here because of 7's in the row and column, so this must be 7 here. Where is 1 now in box 5? Can't be here, and this is filled out, so this must be 1 here. That leaves 3 and 9 remaining. This can't be 9 because of 9 in the column, so this is 3 and this is 9. 6 eliminates 6 here, so this is 5 and 6, which makes this an odd digit, and this an even digit. We have 4 evens in row 4, so that leaves the remaining digits as odd. We have 5 odds in row 6, which means the remaining digits are even. 2 cannot be here because of 2 in the column, so this is 2 here. That leaves 4 remaining in row 6. We have 5 and 9 remaining in row 4, so that's fine. Okay, remaining digits in column 4 are 3 and 5. Remaining digits in column 5 are 2, 7, and not 2, yeah, 2, 7, and 9. Well, this can't be, it can't be 2 because it's odd. Can't be 9, so this is 7, not 9, not 2. That 4, this makes this 9, and this makes that 2. Remaining digit here is a 1, and we have the remaining digits as 4 and 8 in column 6. And this can't be 8 because of 8 in the rest in that row, so this is 4, that's 8. Okay, remaining possible digits in row 8. We have 3, 5, 2, and 6. 2, 3, 5, and 6. 2 cannot be here. 2 cannot be here because of 2's in the columns. So where's the 2? It has to be here. Well, what digits are 4 or more away from 2? Cannot be 3 or 5, so it must be 6. So therefore, this is 6. This cannot be 3 or 6 anymore, so that makes this 5, which makes this can't be 5. That's 3, which makes that 5. So again, these are 2 even digits. This must be odd. 5 eliminates 5 here, so this is 9 and 5. 2 here eliminates 2 here, so it's 7 and 2, which means 7 is odd, 2 is even. 2 can be next to 6, 7, 8, 9 on a whisper 4 line, cannot be 6 or 8 or 7, so that forces this to be 9 because of the digits in the row and the column. So 9 is odd. 9 can be next to 1 through 5, cannot be 1, 5, or 2, so this is 3 or 4 that it's next to. And this is 3 or 4. Remaining digit in column 3 is a 7 and is odd. And these digits add up to 25. And we have 5, 6, and 9, which adds up to 20. Plus 2 is 22, so this must be 3, which makes this a 4. Remaining digits in column 1 are 1 and 8. This must be 1. That has to be 8 because of the 1 and 8 in the row. And this leaves this as a 3 and this as a 4. We don't celebrate with 3 in the corner, though. Yeah, I mean, fairly straightforward. Pretty easy. Yeah, just a very nice little puzzle. Flowed very well throughout and was just, pretty solid. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.